Hello again, and welcome to our final session of our humidification webinar series. Today, we're going to be bringing together all of the topics that we've talked about in previous sessions with a hands-on look at DriSteam's software called DriCalc, which is our powerful selection software. I'm joined by my colleague, David Baird, our expert application engineer, who's going to show us how DriCalc can streamline humidifier selection, system sizing, and even coordination with tools like BIM. So, David, how does DriCalc connect all of the dots that we've talked about in our previous sessions?
As we were going through these different series, it was a lot of different questions and pieces of data that we had to collect. What is airflow volumes? What is my starting conditions? What's my ending conditions? What utilities do I have? Where is it going to be placed? All of those different things that have to come together. And ultimately you want to come, what is my solution? What's it going to be? How big is it? How do I connect to it? All of those pieces you've got to get. And DriCalc is the way to sum all of that together. You just simply put in all those little nuggets of information that we've collected along the way. Hey, what's the airflow volume? For me, as an example, I may be helping a customer and I don't know what the outside air conditions are. I can look that up because you may be working with an application outside your territory and be able to quickly look that up and hey, now you've got that input. And so that's a key piece, understanding that. And then just thinking through, okay, how big is it? We talked about what bypass and all those different things. Well, you can now see the direct impact of if I put tubes close together, far apart, if I don't break it off, you can actually see each of those different pieces. It's one thing to conceptually talk about it, but to really see, well, how does that change those factors? How much space do I need in my air handler for an adiabatic type system, a water-based system, or a steam system? You need to actually be able to see that. And all of those decisions, all those pieces of data come in to give you, hey, this is what it means. Here's how you put it all together.
Sure. So David, could you provide a demonstration of how easy it is to use the DriCalc software?
Sometimes the best way is actually seeing it, touching it, and understanding how it makes it really simple and easy. And it guides you through the whole process. So in order to do this demonstration, first we have to get to DriCalc, and that can be accessed through DriSteam.com. I've already done that here. And once you've done that, creating a project is the key piece, and we're just going to call this a test system. By doing that, the description, we can just call it test example. We're just going to ask, is this a new construction? Is it a new building? We're just going to consider this a renovation, and it's going to be for a manufacturer of paper and allied products. Yeah, and we could just choose, it's a basic design, it's DriSteam. And we're just gets us the base information. We're going to use everything in English units. And now we've created basically the project. Think of it as an entire building. Then you get into, okay, what are the specific pieces? Oh, we're going to connect it into an air handler. So we're going to call this AHU1. And then the technology type, we've been focusing on isothermal or steam-based systems. So we're going to continue down that path. And we want to do a steam generator to make the steam and then to disperse the steam. We can do it as just one part where we need to make steam or disperse steam, but let's do both and kind of see how they pair together. By doing that, now we come in here and understanding how is the airflow going. And let's say we have a mixed air system and it's going into an air handler. So we have, let's say, a 10,000 CFM system, and we want a target of 70 degrees and 40%. That happens to be kind of a comfort level, typical buildings. And where are we putting this? Let's say we're putting it in our neighborhood here in Minneapolis. I'm just going to pull in what is the design conditions for outdoors. Pretty cold and dry. Now this amount of outdoor air, let's say it's 20%. Not all of it's coming in from outside. So we have a load. Now we have an idea if that's the correct one, or maybe somebody had an idea, no, it needs to be 60 pounds an hour. You can modify that. Then we pull in this application stuff. It's going to be placed in the US, and the energy source is going to be electricity. And we're going to use clean water for it, kind of used to filter products later down the road. Now that we've got that, then it goes, how are we going to install this dispersion within the space? Are we going to have it all fit inside the air handler, which it must? The question is, are trapping going to fit outside of it, or is it going to fit with inside? And you'd rather have everything inside. And so that moves to option D or E, and it simply becomes a choice. Are you going to blank off around the panel because there's trapping that happens underneath and the air will go right underneath it? Or do you want to stop it and force all the air to go through it? The implication is if you don't stop the air going through it, the volume of steam goes into less volume of air. Therefore, it will take longer for it to absorb. So we're going to assume that it's going to be blanked off, a little bit increase in pressure drop, but a shorter distance in terms of how long it takes for that steam to absorb. Now that we get into the dimensions, let's say that this is a 72 by 60 air handler in terms of dimensions with 2-inch walls. And then the leaving air temperature, I'm just going to assume is 55 degrees. And we have no more than 18 inches for the steam to absorb. We're going to connect it inside. And we get a solution set. And there's different performance. You'll notice that the non-winding distance here is as short as 7 inches, or as long as 16. It meets the criteria that I've set and changes the number of tubes. More tubes means more contact points, shorter that the distance will be. We could put that even closer together if we wanted to, but this meets the requirements that we're looking for. And the rapid absorb comes as parts and pieces. So the NP is probably the most economical solution in addition to providing the performance looking for. And we can see here, okay, there's very little pressure drop because the tubes are spaced far apart. And then we see this will fit within that space. Even though we started with a 72 by 60 air handler, this area that the unit will be, the airflow will go through a 66 by 42, a little bit smaller, allowing clearances for all the rest of the headers and trapping to fit with inside. We see a slight increase in air velocity because it's going through a smaller space. And we have some losses because some of that steam is in a cooler airstream that will collapse. We can get into some options. Let's say they wanted it in 304 material for the casing going around it. And when we talk about that face dimension, you can see clearly where those tubes are. And then you've got all this framing around it. That's why we have the larger dimension versus the smaller dimension. We're going to ship it assembled, and we don't need seismic. So we've completed a dispersion. Now it's a matter of how do we create the steam that goes into it in the first place. And we have to know the voltage and the phase. Again, this is knowing the inputs available. That seems reasonable. Let's just go with a unit that meets or exceeds the requirement. Again, when the inefficiencies are taken into account, we're at 63 pounds. So this is the right size unit and the amp draw. A number of different options that we can choose. Again, we'll put this indoors per se. We can kind of skip through a lot of these, and then looking at the connections. You'll notice that one type is hose and one is coupling. We probably want to match the same style. If we choose, now we're working with a threaded connection on both sides, and the connection size matches, makes installation easy. If we had just a different unit, and this is still part of that same building, but we have another one that's connected to a boiler as an example, you don't need to make the steam, it's already available. We can do this as a dispersion only. Or we could have done this same example, assuming the generator was already there, we could go through and do that. Again, we'll choose an air handler. This time, we'll treat it as a makeup air system. We know all the air is coming in from outside, trying to hit a space target. In this case, let's just make it a 20,000 CFM system, a little bit larger. Again, trying to hit a comfort level, so 70 and 40 for space conditions, temperature, and RH. Again, we're going to put it in our backyard here in Minneapolis. all that's coming in from outside. Therefore, our load is much larger. There's a lot more volume of air that we're bringing through this unit, so we have to add the moisture to it. In this case, we're going to do direct steam because it's coming off a boiler. Now we need to know what the pressure is. Let's say we've got 10 psi. And then what type of cleanliness we're looking for. Bronze, probably more common. Stainless if you're working for a more purity type application. We'll just go with the bronze application. This looks very similar. This time, let's not blank off around it. Let's let the air go through it, meaning we'll save a little bit of pressure drop. And our unit's larger, so let's go 96 by 60. Again, 2-inch walls. Still a leaving temperature of 55 degrees. And this time we want it to happen shorter. All this mass, we don't want to have a longer section that's needed. We want to insulate the tubes to keep the steam as hot as possible and not collapse back into condensate. Taking this off would reduce the efficiency of the unit. And we can see our solution set. Meaning we're trying to put too much in. Let's warm it up a little bit. And warm it up a little bit more. Given a couple of choices, and because of that, we didn't blank off around it. It took longer to absorb, driving the RH higher, which is why I had to raise the temperature up. The message is kind of alert you to that problem. Had I gone to, we'll try this. If we had blanked it off instead, we likely could have gotten by with a much lower temperature. That's just one of those impacts of what that is. We can choose an MP. By not blanking it off, it takes longer to absorb, the leaving RH is too high, so you can see a direct impact on that consideration. Either of them are leaving space, it's just a matter of how much of the air is going through it.
Now, David, what you just showed there with showing those different choices as far as like, are we blanking it off or not, is that kind of how someone could use the system to see how different design considerations would ultimately impact the design and performance?
Definitely. How you're going to install it, as an example, directly has an impact, as we use this example. If the temperature was colder, we can see the impact of that as well. Quickly model that. Let's say it's leaving at 54 degrees. The non-budding distance will increase a little bit. If we change the number of tube spacing, all of these different factors will come into play, and you can see directly what does that mean for the unit selection. Maybe the inefficiencies go up a little bit. Notice that these are all at 3-inch on centers. If we wanted to see, if we expanded the tube centers a little bit, we can see, in this case we can't because it's as tight as it can be. Oh, so here we go. You can see we can get different centers, and therefore having more tubes, more contact points, the shorter the non-budding distance. If we push them further apart, notice our non-budding distance continues to increase, meaning that air handling needs to be longer and longer as a result. Using the show dispersion always gives you that recommended solution set. That's what's intended to do. And I'd still have all the options to be able to consider. And now, okay, do I want to use one valve? Do I want to use two valves? Giving a little bit more turn down possibly on it. In this case, okay, we've only got one connection that matches. So it helps kind of guide through and balance those different decision points.
Excellent. So let's say we've gone in here, we've created our different systems that are going to be part of our larger project here. What sort of information can I then get out of DriCalc to share with other people within my organization or other organizations that are handling some of the work with this project?
And that's a relevant question, because just because you loaded all this information into the software, you don't want it to stay there because it's your project. What you often would do is, let's generate a report, and the detailed report tends to be the most common. It goes through all of the stuff that we happen to put together. It shows you an airflow schematic as to how is the air changing based on the inputs, gives you all of the information you put in, how it came up with that load in this case, and then here's the performance, the sizes of it. We had that face dimension, and then we can see the overall dimension, and you'll notice that this overall dimension still fits within that same air handler size, including trapping. Get some weight information. We can see all of the performance pieces of it, the non-wetting distance, how much heat gain, the air velocity, and then we can come down here and get an idea. This is roughly what the product looks like and the overall size, which can be really helpful from a coordination standpoint.
Excellent. So what are some of the other tools that DriSteem offers to support humidification systems beyond just DriCalc?
Other tools you can get out of DriCalc are submittals of parts and pieces. As an example, if I choose the same system level reports are just for that air handler that I choose, the one that I've highlighted. The project level is everything associated with it.
Sure.
Some extra piece of information, wiring diagrams as an example, instruction specifications, which can be helpful. You can get a schedule as well. Quick high-level overview of what the thing is, what's included in the project that you might include can share with an engineer. Otherwise, on our website, we also have information about BIM content. And you got a representative idea out of DriCalc, but you can get the actual items and be able to do that. And we've got them hosted a couple of different places. So I'm just going out here to BIM object, and we looked at an Ultrasorb MP as an example. After logging in, and continue. Get this MP. One in Revit model. And we can pull that down.
And it looks like this site here, this BIM Objects, offers a lot of different file types associated with all these 3D models. So that should be really helpful, no matter what software you're using. You should be able to import this.
And then once you have the software, then you can be able to view it and get much more. Here's exactly what your piece is. Here's the width, the height, the spacing, the connections. All of that can be covered off in that BIM model, which can be really helpful from a coordination standpoint.
Sure. And so let's say that we have our AHU, it's in design lock, and we are wanting to integrate the DriSteem 3D model, but that specific unit that we want to install just for our own peace of mind. How might I go about getting like our custom 3D model from DriSteem so we can integrate that into our design software?
Well, BIM is one of those ways. The other is you can take that detail report and get an as-built drawing to understand exactly what yours looks like in a 2D fashion. And we can even export that as a step file with our drafting team. That can really help from a coordination to see, hey, how big this is, what does that look like, the connections, how does it fit within your air handler, how much space do I have to leave below for trapping. That can be really helpful from a coordination standpoint.
Well, excellent. Well, hey, David, I really appreciate you going through this demo of DriCalc and BIM Objects. Seems like DriSteem has everyone covered as far as the tools that they need in order to successfully put a humidification solution inside an air handler. And that's a wrap on our webcast series on how to size and select the best humidification system for your application. Really want to thank you for joining us in all of these different discussions. And I really want to thank my colleague, David Baird, for participating in all of this and sharing his expertise with all of us. So remember, if you ever need any resources around humidification, you can access a wealth of knowledge at DriSteem.com. And you can also go there to register for using DriCalc, so you can see the direct impact of whatever solution you are choosing on your overall design. Thank you again for your time, and we look forward to seeing you again sometime soon.